not here. The size of the multiplier depends on the fraction of additional income generated in each round that is spent in the next round. That is on the marginal 17.11. 17.11. This is a very important graph because this actually allows us to let us know what exactly happens with this multiplier effect. Right, and what I want you guys to keep in mind is that, remember, at the end of the day, when we're talking about, the multiplier as a whole, remember that our equation states the following. A is equals to y. That's where equilibrium would be, right? A is equals to y. So as long as A is greater than y, then the multiplier effect will keep going. However, if A is less than y, then obviously that the multiplier effect doesn't really have an effect on that. Okay, so this is the scenario that we're working with. So if we look at, for instance, your figure 17.11, total income and aggregate spending. Tell me, at point E1, what is the aggregate spending and what is the total income? Let me know in the chat. At what amount is the aggregate spending and total income at E1? The total spending at E1 and the total income. 100% okay, that is exactly it. It is 10 million. But now something interesting has happened because and that's aggregate spending and total income, exactly the same. But something interesting has happened, right? Where we find from E1 until Z, there has been an increase in aggregate spending. And obviously we realize that this increase is investment spending being spent. Investment spending being spent, right? So we are now moving from 10 to what? What's the aggregate spending that we get to at 10? After 10 at point Z, what's the aggregate spending at that point in time? And we're going to work through this slowly just so that we obviously get it. Good attempt. So in this case, it's actually 22 million at point Z. If you look at the 22 point Z, yes, 100%. So now we realize that at your 22 million, when your aggregate spending in this case, guys, is 22 million. So your aggregate spending in this case is 22 million. But guess what? Your Y, on the other hand, is equals to 10 million still. Right? So essentially what ends up happening as a result of that, guys, is that we're obviously going to produce a whole lot more. So the difference, the 12 million difference, is multiplied by the multiplier, in which case, in this case, the multiplier was given in an example, which is 0.6. And if you've got your calculator next to you, please put in 12 times 0.6 to get ourselves to 22 million. Yes, madam? Which should be 7.2. So you'll find now that when we add that, it's now on both sides. We realize that, hey, look, we're at equilibrium on Y. We're at equilibrium where A is equals to Y at 22 million apiece. At 22 million apiece. But remember, whilst we're at equilibrium being A is equals to Y, we are not on A2. We're not on A2. We're not on A2. So therefore, we take that 7.2 and we multiply it again by 0.6, right? Or rather, first and foremost, that 7.2, we add towards your, at 22 million on total income. We add that 7.2 million to get to X, right? Now, obviously, you won't be able to read that on your graph, but that should be about 29 million.2. So it'll be 29 million.2 aggregate spending wise, but it will not necessarily be the same. So we'll realize that here in our second scenario, your aggregate spending is equals to 29.2, which was 22 plus 7.2. But your Y is now equals to 22 million, which means that we're, once again, guys, we are going to produce again, right? We're going to produce again. So we take that 7.2 and we multiply it by 0.6. And if you do that, let me know what you get. Isona, Kamokelo, and Tobizodo, let me know. 7.2 times 0.6. Absolutely. Absolutely. You'd have to decrease the, you just change the decimal point there, Kamokelo, but you're on the money. You got the right digit, right? Guys, and we'll continue doing this until we get to where your A2, which is the function of A, aggregate spending, is equals to your 45-degree line, which is A is equals to Y, right? We're going to keep multiplying until we get to that space. So where we would have had initial investment of 12 million, that obviously changes from 12 million. The effect that it has is actually 30 million. Because we started off with 10 and we moved all the way until about 40 million. 40 million times minus 10 equals 30 million. So one will just put in 12 million, but as a result of that 12 million, they have 30 million that results from that, right? And that's the multiplier effect working. Okay, so let's shift on to page 373. And what's very important on page 373 would be the following, right? It gives us an equation to show the total increase. So it'll be Y, which is income, the change in income or production is equal to the multiplier, which is 1 over 1 minus C, multiplied by the change in investment spending. Okay, the change in investment spending. So in this case, what we found, right, with this specific formula was that 1 over 1 minus 0.6 multiplied by the change in investment spending, which is 12 million, which has been put into this. This would be 0.4 over 1 times 12 million, which would then be 12.2, 2.5, I mean to say, times 12. And this would be then 30 million. So this is the simpler way of getting to that result. This is the simpler way of getting to that result, 30 million. Okay. Now, what's important about this, guys, and I'm going to put it into boom. would be the following. Right? If we're going to substitute to find what the change in investment should be in order to get to full income, or to full employment, it will then be y is equals to, I'm saying change in y in this case is equals to 1 over 1 minus c multiplied by the change in I, but now we're looking for the change in I, and therefore it'll be change in I is equals to your full employment, YF, multiplied by 1 minus C. Please make sure that you have written this one out. This is a very important one. Very, very important one. Very, very important one. All right. Let's move right along. Let's move right along. Let's move right along. Right. So we end this chapter with page 374, where it says the Simple Keynesian Model, a brief summary. Right, and on the, it will be the second paragraph, towards the right, it says the multiplier is the ratio between a change in income, A, and a change in autonomous spending, which causes a change in income. The multiplier can never be less than 1. In our present model, the size depends on the marginal propensity to consume, that is the slope of the aggregate spending function. The greater the value of C, the greater the multiplier will be. The equation for the multiplier of this chapter is A is equals to the change in Y, or the change in autonomous spending, which is 1 over 1 minus C. I'm still reading. In figure 17.12, which is on page 365, provides a graphical summary of the multiplier. When autonomous spending increases from A1 to A2, total income increases from Y1 to Y2. The multiplier is the ratio between the change in income and the change in autonomous spending. Right, still on page 375. I want you to highlight the following. It's in the second paragraph. It says, in the model developed in this chapter, production and income are determined by spending. Right? The higher the level of spending, the higher the equilibrium level of income will be. If households suddenly start saving a greater portion of their income, aggregate spending and income will fall. The strange result is called the paradox thrift. And this is what the paradox of the thrift is. And it says here in box 17.6, in chapter 1, we explain the fallacy of consumption or composition, fallacy of composition. This is a logical fallacy of assuming that what is true for the part is also true for the whole. One of the examples we mentioned was the paradox of thrift. The paradox of thrift is the fact that while an individual or single household can increase its income by saving more, the same result does not hold for society as a whole. And we see that the more the society saves, the less the economy actually works. We want you to spend your money. We want you to spend your money, guys. And that then concludes chapter 17, which is a simple Keynesian model. Now, what I'd want us to do would be to just do the following exercise, and I'll give you guys about 10 minutes to do so. You want to do the following exercise, just 10 minutes to do so. All right, just to see whether things have solidified. Just to see whether things have solidified. I'm just changing something here quickly. Change in I is equals to YF. It's just chapter 17. What's the worst that could happen? What's the worst that could happen? Let's do some work. And the good news is that that means that you're ready for test 2. You go through the work, you're ready for test 2. How about that? How about that? Right. So I want us to now focus on the following question. And guys, I would need you to be honest all the way throughout. If you don't understand something, please say something. Don't keep it to yourself. Say something. I want you to work through question 7. And I'll give you until not half past, 40 minutes past 3 to work through question 7. Work through question 7, and I'll give you about 10 minutes to do so. Well, 12, because it's going to be 40 past 3. If you have any questions, please go ahead and ask. I will be in the background, and we'll just work through this because I really want us to make sure that we understand what's going on. All right, so let's work through question 7, 10 marks, and get those 10 marks. Okay, all right. Let's see. Everybody else, do you agree with Madam Tommy Zodwa, Isona, Kamahelo, Mukhao, and Obakhanetsi? Let me know if you guys agree, whether you want us to work through this together, or whether you'd want to do it by yourself. Tommy Zodwa says, no, we've got to do it together. Everybody else, let me know what your take is. Okay. Not a problem. Then let's do it. Let's do it. Let's do it. Let's do it. All right, guys. I'm going to work on my. I'm going to work on this actual sheet, so you will see it. What I would advise you to do is get your paper, get your pen, and get your calculator. Let me know when you have all 3 in front of you: your pen, your paper, and your calculator. Give me a thumbs up once that's the case. I need at least 3 people to obviously give me a thumbs up, and then I'll continue. Awesome, Toby Zodo. I feel like you were born ready. I feel like you were born ready. Isona, Mukhao, Kamatelo, let me know. Paper, pen, and awesome. Mukhao, Isona, I'm waiting for you, man. Waiting for one more. Good stuff. All right, so first things first, we need to look at the question and try to understand what exactly they want from us. So it says here, use the graph to illustrate the equilibrium level. Okay. Equilibrium level of income. Interesting. Equilibrium level of income. So when we talk about equilibrium level of income, already we know that that specific equation is y0 is equals to the multiplier being 1 over 1 minus c, right? Multiplied by c plus I, right? Because right now we're dealing with the simple Keynesian model, which only deals with households and firms. Let's continue reading. In an economy of which total spending is comprised of consumption and investment only, right? So C plus I. In this economy, the consumption function is C is equals to 150 plus 2/3 of Y, and the level of autonomous spending is 100 million. Great. Marks will be awarded for indicating the following on your graph. Level of autonomous consumption. Level of autonomous consumption. Great. All right, so let's begin. Let's begin. And this will be messy, but I'm sure you'll be able to see from where you are. Let's begin. Let's begin. All right, so we have the 0 over here, and we have your A over here, and then we've got your Y over here as well. Okay. Now, the first thing that we're looking for is your autonomous consumption, right? Your autonomous consumption. And just let me know in the chat, when it comes to your autonomous consumption, right? What would that be when you're looking at your consumption function? What number would that be? Let me know in the chat. Let me know in the chat what number. And if you don't know, also let me know that you don't know so that I can just, take you through that as well. 100%. No, hey, well, you're guessing right. So we'll then say C bar is equals to 150. Right, so there's 150 over there. So already we've got this mark. We've shown autonomous consumption. Now it says the level of total autonomous spending. And total autonomous spending, total autonomous spending is C bar plus I bar, right? So C bar plus I bar is equals to what, guys? We already know there's 150 here. What's the digit that's missing? Plus what? Plus autonomous. So we've already got autonomous consumption, yes, which is 150, right? Which we've already put into the graph. But now there's another I, which is autonomous investment. What is autonomous investment in this case? No, that would be the consumption function. And in this case, you're looking at marginal propensity to consume would be 2/3 over y, right? So it's 100%. It's 100. It's 100. So therefore, total autonomous spending would then be 250, being the 100 plus the 150. Now we need to obviously represent this on our graph, and we do so by adding the 100 here, and therefore we have 250, which is C bar plus I bar is equals to 250. Perfect. Now we're done with that. Now they're asking us for a point of equilibrium. Now in order to get a point of equilibrium, we need two things. The first thing that we need is a 45-degree line, right? So we put our 45-degree line over there where A is equals to Y. And that's the first thing. But then we also need to have a aggregate spending function, right? And how do we get that? Well, that's very simple. It's A is equal to C plus I. And we know for a fact that C in this case is 150 plus 2/3 of Y. And we know that I is 100. And this would then be 250 plus 2/3. And as a result of this, guys, as a result of this, this is now our line. So we take another line here, and then we go, and this is where A is equals to 250 plus 3, sorry, plus 2 over 3. Y. All right, and where's our equilibrium? Let me know in the chat. Where's our equilibrium? You say C? Not necessarily. Not necessarily. Our equilibrium point, sorry, our equilibrium point. 100%, 100%, 100%. It's where the two lines intercept, right here, E1. right? E1. So then after that, I draw a line representing my equilibrium level of income. Then I draw another line showing my equilibrium level of spending. No bar on top, just an A0. Okay, so we've done the point of equilibrium. Now they're asking us a simple question. They say, what is the equilibrium level of national income? You must calculate this and indicate the actual amount on your graph. Easy peasy, Captain Squeezy. Got this. So it's y1 minus 1c. Then you've got your c plus I. Right, autonomous c and autonomous I. Now, what is our small c in this case, guys? Let me know. Our marginal propensity to consume, what is that? It's 1 minus what? What is that marginal propensity to consume as I figure this one out? 2, 5, 0. So is it y6? Not necessarily, no. It's 1 minus, what's c? What's small c, guys? What's small c? Yes, consumption. It is the propensity, marginal propensity to consume. As in this case, that would be 2 over 3. It would be 2 over 3. Okay, now let's do the maths. Let's do the maths. This is 1 over 1 over 3 multiplied by 250. Now, simple math tells me that when you see an equation like this, you put the 3 on top. And this then becomes 3 times 250. Right, and let me know. 3 times 250 equals. Brilliant. On a Friday afternoon, your minds are still fresh. I love it. 750. Now it says indicate that on the graph, and that's where I'll put 750 over here. And I'll put 750 over here as well. Okay, if you can't see, I'd say zoom in. You still have that function. Zoom in. Definitely zoom in into that. All right, perfect. So now we found the equilibrium level of national income. We've also found the equilibrium level of spending as well, because remember, y0 is equals to a0. Okay, your aggregate, your equilibrium when it comes to your aggregate spending is also the same as your equilibrium when it comes to your income as well, or production. All right, so brilliant there. Then it talks about the gradient of the total spending function. The gradient of the total spending function. What is the gradient, guys? Let me know in the chat. What is the gradient of the spending function? Being a is equals to 250 plus 2/3 y. Yes, the slope. Give me the number though. Give me the number. What's the number? What's the number we're looking for there? That's fine. That's fine. That's fine. So in this case, guys, the gradient is the consumption, sorry, the marginal propensity to consume, which is 2/3. Right, and we showed it in this line over here, which is a is equals to 250 2/3 of y plus 2/3 of y. Okay, so in this case, our gradient is 2 over 3y. Right, now the next thing that talks about is the full employment level of income, 1,050 million. But remember, in this case, guys, this has got nothing to do with anything, right? Because remember, all we need to do is show the equilibrium level of income. So this is not something that we necessarily have to answer here and now, right? But if we decided to put it onto the graph, would simply just go y, f, and then would go up until we get to the A is equals to Y, and YF would be 1050. All right, so that's how we would show that. Now, the next question here asks us a very, very interesting question. It says, calculate the change in investment required to attain the full employment level of income. And the equation here, guys, is the change in investment is equal to your income or production, open brackets, 1 minus C. Okay, so in this case, guys, YF is 1050. And we say 1 minus, what's the C, guys? What's the consumption to the marginal propensity to consume? Put it into the chat. What is the marginal propensity to consume? Put it in the chat. Bingo. It's 2 over 3. All right, and if we do what we need to do there, do that with your calculators. 1050, open brackets, 1 minus 2/3. What do you get? You say 350, Michal. Ntombi Zoda, let me know if you got the same. Kamahelo, give me a shout in that regard. Misona, let me know if you also got that as well. And let me also know what's going on. Awesome, great, and that is the answer. 350. Guys, if you do this, because this I believe is 2 marks, and then obviously the first one is 8 marks. So here you'll have your 8 marks. Well done. And then here you'll have your 2 marks. Well done. And that's it. You got your 10 marks, guys. You got your 10 marks. And I will be asking a lot of questions around this because I obviously want you guys to pass and pass well. Does it make sense now that we've done a bit of work around it? Let me know in the chat. Give me a thumbs up. That's are those tears of joy in Tombi's Odwa? Are those tears of joy? I certainly hope that they are tears of joy. Oh wow. There you guys. They don't worry about it. I think you just need to practice, man. The more you practice, the better. Yes, the gradient will always be C. The gradient will always be C. Okay, and maybe now is a very good time for me to just go through this. Whenever you have a line function, guys, and I'm just going to do this just for you guys because I can see that I don't know if you guys were there for the first one. We went through the simple Keynesian model, right? A is equals to C plus I, right? Now C in this case, guys, there's a specific function there, and that C is equals to C plus CY. C, the first C being autonomous consumption, and the second C being induced consumption. Now, what's important here is that this would be the y-intercept. And remember, the definition of y-intercept is that when x is 0, what is y? Right? When x is 0, what is y? Now, this small c would then be what we call your gradient. And it will always be the case. Always. It will always be the case. So when you see this, this is basically the function of that line. It's the function of that line. All right. I hope that answers your question in full, Kamogelo. Give me a thumbs up if that's the case. Yes, induced consumption would be, so induced consumption in this case would be the full C times Y. This is induced consumption. Where Y is income. Absolutely. C is the marginal propensity to consume, which is its other name and the more important name. And I'm just going to put there marginal propensity to consume as well. Whereas your normal C, or rather your C with a bar, is what we call autonomous consumption. Yes, Ntobizola, please do that. Go through chapter 17 again and without panicking. You've got this. You've got this. No, spending. Spending in this case, remember, is this aggregate spending as a whole. Yeah, no problem. Ntobizola, you've got this. You've got this. Go through it again without panicking. You've got this. Right, guys. We've got our 10-minute break now. Let's get into our 10-minute break. And then from 4 to 5, we're going to go through the Keynesian model with government and foreign sector. And then we'll be done with the Keynesian model as a whole. And I'll be away from the computer, but I will be back at exactly 4 o'clock. All right, guys, I'm back. I'm back. Let's push this final stretch, make the most of it, make the most of the time that we have, and then obviously I'll leave you with a couple of exercises sometime next week specifically. Sometime next week specifically. We're on page 380, sorry, page 380. And let me know as soon as you're there. Page 380, just give me a thumbs up in the chat. Great in Tombi Zodwa. Awesome. Hello. Everybody else, where you at? Where you at? Okay, perfect. Perfect. All right then, guys. The first thing we realize is that our simple Keynesian model said A is equals to C plus I. But now that we're adding government, right? Now that we're adding government, that means that it's plus. Let me know in the chat what the symbol for government is. The algebraic symbol for government. I'm just going to just stop a couple of noises here. Absolutely, it's G. It's G. So we put a G over here as well. Now, you guys will remember something called the fiscal policy. The fiscal policy. And remind me, what does the fiscal policy entail when it comes down to government as a whole or the government sector? What does the fiscal policy entail? What are the two instruments used in the fiscal policy? Let me know in the chat. Government spending, 100% Kamahelo. One more left, one more left. Absolutely. Tax. So government policy, or rather the government sector as a whole, is about government spending and taxes. Now let's listen to what the rest of the book has to say around this. And we're going to start with government spending, and then from government spending, guys, we'll move into taxes. I'll see how far we can get today. Just looking at the time, and I don't want to press for the sake of just pressing sake. Although I do think that it's pretty simple stuff to understand, but maybe we'll take it one step at a time. So in this case, guys, when it comes to government spending, right, government spending as a whole, just government spending in and of itself, we realize that government spending is dependent on political issues, right? It's about politics as a whole. Whatever the politician decides and whatever the bureaucrats decide, they then sit down and then they spend accordingly, right? You'll find in the budget plan of every year that typically shows what's going to be happening that year from a government spending perspective, very politically based. So it's got nothing to do with income. And remember our graph around income is shown by the following, where your y-axis would be government spending and your income would be y. Now, because government spending is got nothing to do with spending or income as a whole, we then have it as autonomous, and therefore it is just a straight line. Now, I'm sure you've seen this line before, and this line you've seen when we talked about investment spending as well, which is also autonomous. So what we do now is we basically show G with an autonomous sign on top of it, right? So G becomes G bar, which just shows that at the end of the day, government spending has got nothing to do, absolutely nothing to do with income. But that being said, when it comes to taxes, guys, tell me, when it comes to taxes, right? When it comes to taxes, do taxes have an effect on income? Is there a relationship there? Yes or no? Tell me more about this relationship. Yes, I think. That's fine. Let's think. Let's think. Let me know, what is that? What effects do the two have on each other? What effect do the two have on each other? Taxes and income. Are they positively related or negatively related? Tax and income. Negatively, right? So in this case, when it comes down, and when I hear you say negative, I presume you mean in the sense that, you get less of an income. But basically, when it comes to taxes as a whole, it's positively related to income. The more income you have, the more taxes are paid. The more income you have, the more taxes are paid. And this is shown by the following curve. And we'll put here taxes in this case, with income on this side. And this is what we call small t, which is taxes and income. And the gradient here is t. All right. So just keep this in mind. So when we talk about taxes, right, in this case, the small t, it affects your income. But when you look at government spending, it doesn't affect your income. Okay, now the full equation then begins to change. And remember, because it affects your income, it obviously means the following. And I'm going to put on one equation, and then from that one equation, we'll then begin some highlighting. Your income, obviously, sorry, your taxes in this case is equals to your tax rate times your income. That is the equation for that. Okay. So now let's break down this equation a bit further, right? And then we'll obviously just show a couple of shifts of the curve that we currently have. So this is A is equals to C, and C is C bar plus CY plus I bar plus G bar. But now we realize that when we look at disposable income as a whole, I just want to make sure I'm on the money here as well. We realize that that is Y, right? So this therefore becomes C bar plus C, small c, 1 minus T plus I bar plus G bar. So that's the full equation as is. Sorry, that looks very, very bad. So I'm going to just do that again. That's A is equals to C 1 minus T Y plus C, excuse me, plus government spending. So now this becomes our total graph, not graph, sorry, our total function. All right, now on our graphs, we'll also just show some shifts as well, and we'll work on some of that as well. So let's go back and start some highlighting, because I'm sure once you start highlighting, this information will solidify even more. Okay, so on page 380, under the Keynesian model with a government sector, just a sentence above the bullet points, it reads as follows. The inclusion of the government means that we have to consider the impact of government spending G and taxes T on the level of aggregate spending A, the multiplier, and the equilibrium income Y. Okay. Now on 380, still under government spending, you'll find in bold, government spending is essentially a political issue. I want that full sentence highlighted. The important point is that government spending is an essentially political issue. In other words, government spending is related to political objectives rather than to level of income Y. In fact, government spending G has often been increased after income Y has fallen. There's no systematic relationship between G and Y. In symbols, we express this as G is equals to autonomous government spending. And then we obviously have our graph there, figure 118.1, that basically shows that relationship as well. That government spending is not due to income. Instead, it is due to political issue. All right. Now on page 381, right, we had our first curve that was A is equals to C plus I, right, which is consumer spending plus your investment spending. Now all we do is we add G, which is government spending. And as a result of adding G, our y-intercept increases, which means our autonomous spending increases. And this obviously shifts our total product and total income as well. And you see that from the first equilibrium to the second equilibrium point, E1 to E2, E1 to E2. Guys, stop me if nothing's making sense. I'll keep going until further notice. On page 382, page 382, and I'll just draw this out quickly, but let's highlight first. It says that the impact of government spending G may be summarized as by considering three aspects mentioned at the beginning of this section. And think of the three bullet points that are there. The introduction of government spending G results in higher level of aggregate spending A, leaves the multiplier unchanged, results in higher equilibrium level of income, ceteris paribus, and it follows that increases in government spending can be used to raise the level of production and income. Now, remember in our previous statement, and I'm just going to go through this again. In our previous statement, guys, you had your A is equals to C plus I. But now in this case, guys, we've added G. We've added G here. We've added G. So our multiplier for now, and it's going to change very quickly. From now, our multiplier is still 1 C bar plus I bar plus G bar plus CY, right? And therefore, because A is equals to Y, we realize that Y is then equal to CY plus, I'm just going to put autonomous spending, okay, which is just basically your C plus I plus G, right? But we want this CY to go on the other side. So we go Y minus CY is equals to aggregate A. Oh, but there's still more for us to do, because we realize that when we factorize, it then becomes 1 minus C is equal to your aggregate spending. But there's still more for us to do, because we want to remove this 1 minus C from one side and put it to the next. So we multiply it by 1 over 1 minus C. And as a result of that, it becomes 1 over 1 minus C multiplied by the multiply. And this is how we find our equilibrium point for now. It's going to change just now. Right? And that's the equation that you see over there. Now, still on page 382, right? I want you to highlight the thing in bold there. It says, it follows that increases in government spending can be used to raise the level of production and income Y. Great. Now let's move to taxes. Let's move to taxes. It says here, if government wishes to spend, it should levy taxes. In the circular flow, and we know this because government spending is based on taxes, right? If government wishes to spend, it should levy taxes. In the circular flow models introduced in chapter 3, we emphasize that government spending G is an injection into the circular flow of income and spending in the economy. We also indicated that taxes T constitutes a leakage or withdrawal from the circular flow. We would therefore expect that the impact of taxes T would be the opposite of the impact of government spending G. As a general principle, this is indeed the case, but there's a subtle difference between the impact of T and the impact of G. Whereas G affects the level of spending and income in a direct way by adding to the demand for goods and services, taxes T operate in a more indirect fashion. Taxes reduce the income that households have available to spend on goods and services. We say that taxes reduce the disposable or after-tax income of households, with the result that households can afford to purchase fewer goods and services than before. By reducing disposable income, taxes indirectly reduces consumption spending C by households, right? And if you continue going down, you will find the words in bold, not autonomous. And it says, we therefore cannot realistically assume that taxes T are unrelated to income Y. T is therefore, or is clearly not autonomous, as with the case with government spending. To be realistic, we have to assume a link between T, taxes, and income, Y. Right, and there you've got your taxes is equals to, that's equation 18.5, taxes is equals to your tax rate multiplied by your income. Now, graphically, you will see it on page 283, figure 18.3, taxation as a function of income, which is T is equals to TY. T is equals to TY. And now the rabbit hole gets deeper. The rabbit hole gets deeper. Because what we realize is that when it comes to disposable income, right, comes to disposable income, that equals your income minus your tax rate times your income. Okay. And this essentially is, after some factorization, is y, rather in this case they just put y minus t and a y right at the end. Okay, now we've got that sorted. This is equals to your disposable income. Now you remember that your consumption function, because this directly affects your consumption function, we've got your C bar plus your disposable income YD, which is your induced income. But then this goes a bit further, because this then goes C 1 minus T Y. In the chat, just let me know if you're following. Give me a thumbs up if you have understood thus far. It's just been substitution that we've been doing so far. Just some substitution. Let me know in the chat. Give me a thumbs up. I know it's a Friday, but I also know that you guys are pretty serious about life as well. So also let me know. Let me know in the chat whether you're good. I love it. Love it, love it, love it, love it. Come on, struggling with the... Tell me what you're struggling with exactly. Switch on your mic if you have to. Let's get down to the bottom of that.
So I'm just struggling with the, because beforehand it was marginal propensity to consume.
Yeah.
But
Yes.
now it's like disposable income.
I see. Now remember that the marginal propensity to consume has still remained the same because we still have your C over here. The marginal propensity to consume has remained the same. The only difference now is that the disposable income has changed. Before we had complete income, which was just Y. But now that we've got taxes, it means that we've got less income to consume with. I hope that makes sense, Kamosheno.
Makes sense, sir.
Awesome stuff. Awesome stuff. Isona, what's the story there? Let me know what's going on that side. Sorry, I'll get it right. Tell me what's the story there as well. You're a bit quiet for my liking. A bit too quiet for my liking. And Mukhal, I haven't heard from you in a while. Let me also know that you're good. Let me also know that you're good. Okay, so well, that's page 383. Page 383. Let's keep it going and keep it flowing. Now on page 384, page 384, page 384. All right, I just want you to highlight the important to note. When calculating the multiplier with taxes, the calculation in brackets 1 minus t must be made first. The result of this calculation is then multiplied by the marginal propensity to consume C, and then, only then, is the subsequent result subtracted from 1 and inverted to obtain the multiplier. Okay. So let's just see something very quickly. Let's see something very quickly. So far, guys, when it comes to our equation, and I'm going to put this in a different color being red, our equation to find your equilibrium income level has been y is equals to 1 minus 1 minus c, with obviously what your autonomous spending would then be. But now we've realized that c is not by itself. So c, 1 minus c, 1 t, and obviously multiplied by y. And we still multiply this by your aggregate spending. Your autonomous spending, I mean to say. Okay, so this is our new formula when we add taxes. Now, as a result of us adding taxes, what it does is that essentially it decreases the multiplier, and therefore you will find that on our curve, it swivels. It decreases the multiplier. It also decreases the equilibrium level of income as well. But the autonomous spending remains the same because there's a swivel, right? It's just the slope that has changed. The autonomous spending, however, remained exactly the same, right? And we find this on your page 384, the 3 bullet points on the right-hand side. It says the following: the introduction of proportional tax thus leaves autonomous spending unchanged, reduces the multiplier, reduces the equilibrium level of income, ceteris paribus. All right, now graphically on page 385, we see this in our consumption function with the full C is equals to autonomous consumption spending plus the marginal propensity to consume minus 1 minus tax, the tax rate in this case, close bracket, multiplied by your Y. Right, we just see that there's just been a swivel. There's been a change, right, in the slope. It's become a bit not steeper. What's the opposite of steeper? It's become flatter, right? But we look at our autonomous consumption, and that's remained the same. Now, when we look at B, graph B, it's exactly the same thing, right? Our aggregate spending remains the same, but there's a shift from your aggregate spending function, right? But once you add your taxes, which is now the second curve, you move from Y1 to Y2. So the equilibrium level of income has decreased and the multiplier has decreased as well. Give me a thumbs up if we're good to go in that regard. Just give me a quick thumbs up if we're good to go in that regard. Awesome. Ntombizodo, I know I haven't lost you yet. Give me a thumbs up. Give me a thumbs up. The other four are currently ignoring me. You know, Isona, I haven't heard from you yet. Machal, what's the story? What's the story? What's the story? Obonachetsi, hopefully I hear from you soon. Play from you soon. So on page 386, you'll find our multiplier. Tears of joy, I hope. Tears of joy. Right? You'll find our multiplier, not our multiplier, our equation that reads as follows. I'm just a bit excited there. Our equation that reads as follows, which is exactly what is on the board right now. The only difference from this equation is that we go y0 is equals to the multiplier, which is now changed, times your autonomous spending. Right, but right beneath that is very interesting. It says the equilibrium level of income can always be obtained by multiplying autonomous spending by the multiplier. All that changes when government is introduced is that autonomous spending A has an additional component G. The multiplier becomes smaller, thus reducing induced consumption. And then we have here the key model with a government sector, a summary. Right, and I just want to read that. It says the introduction of government spending increases autonomous aggregate spending and raises equilibrium level of income, ceteris paribus. The increase in income is a multiple of the change in autonomous spending. That is, government spending has a multiplier effect on income. Government spending does not, however, affect the size of the multiplier. The introduction of income or the introduction of proportional tax reduces the size of the multiplier and therefore reduces the equilibrium level of income, ceteris paribus. Such a tax affects the spending and income directly via its influence on disposable income. Right. Let's keep it going. Let's keep it going. Let's keep it going. Let's keep it going. On page 388. 388. Let's do this, guys. Let's do this. Let's do this. Let's do this first. I have a theory in my head that we need to work through this together. And as we work through it together, then it makes a bit more sense. So let's go to box 18.1. I hope that is in your book, in Tobizodo. Let me know if that's the case. Box 18.1. It says the impact of including government in the Simple Keynesian Model. All right. We're looking at government now. Now it says there, in Tobizodo, let me know if it's in your book or not. As I'll just continue. If it's not, we just want to start applying what we're learning immediately, as opposed to just a lot more theory. Okay, it says there, suppose a small economy, awesome. Suppose a small economy, economia, it's a terrible country, but let's go. Originally consists of households and firms. Now, when we talk about households and firms, we basically mean the following. A is equals to C plus I, households and firms, where you've got your autonomous C plus your marginal propensity to consume and your multiplied by your income, which is your induced income, plus your autonomous I. So you just already, when they talk about only households and firms, you already put the equation down. There's no government and there's no trade links with the rest of the world. The currency unit is econ. Autonomous consumption is 10 million econs per year. Autonomous consumption. So we're saying C bar is equals to 10 million. econs a year, and households. And households consume 0.6 of each of their additional income. Guys, what is 0.6 in this case? Let me know in the chat. What is 0.6 in this case? Zero point 0.6. What is 0.6 in our line when it comes down to your consumption function? It's in you. Let's hear it. Look at you. Look at you. Yes, exactly that, right? Then on the other hand, we then have your investment, autonomous investment spending, and it says there, because that's the only thing that's missing there, of each additional income. Firms spend 30 million econs on capital goods each year. That is, the investment spending is 30 million econs per year. Ah, there we go. Now from here, guys, we're not even going to waste time. We're going to populate this, right? So this would be 10 plus 0.6 y plus 30, which would be 40 plus 0.6 y. Okay. Now it says there. This means that see, so now they're looking in this case for what is the equilibrium level, right? And now because A is equals to Y, we go, or in this case, let's just get straight to it. Y0 is equals to your multiplier, which is 1 over 1 minus C, multiplied by 40, which is basically A, C plus I, right? This is your autonomous spending. So this is 1 minus 1, and C in this case is 0.6 times 40. And if we continue on this path, we realize that this is 1 over 0.4 times 40. And if we put that into our calculators, let me know what number you get. What number do you get as a result of putting that in your calculator? I've got 100 million. Everybody else, are you on the same money? In Tomizola, let me know. Isona, you said let's go, so let's go. Tell me, what did you get? Good stuff, guys. Good stuff. Good stuff. It's good to hear from you. Right. So in this case, it's 100. So we've already figured that one out. We've already figured that one out. All right. Great stuff. Great stuff. Great stuff. And if you look at your book, you'll find that it's the truth. But now they've added government spending. They've added government spending. So therefore, our equilibrium changes. And now instead, it is y0 is equals to 1 over the multiplier. No, sorry, it's the multiplier. Let me start again. It's y, the equilibrium of income is equals to your multiplier times your aggregate, no, your autonomous spending. Now your multiplier in this case is 1 over 1 minus C. Now remember, we've got taxes here. We've got taxes here. So it's 1 minus T y. And I will definitely share with you as to why we are going through this painstakingly slow. Right, in this case, we have now your government spending added. Tell me, what is your government spending in this scenario? What is your government spending? We're 10 million here plus 30 million. What's your government spending now? Let me know in the chat. The government spending in this case, guys, was it says they're 20 million, right? Suppose the government is then formed and it spends 20 million econs per year. 20 million econs per year. That's fine, not a problem, not a problem, not a problem. We are here to learn. We're here to learn. right? So let's populate this. It's 1 minus 0.6, and our tax there is 1 minus 0.167, and our y in this case, there's no y in this case, we left it out, so I'm just going to take this out completely. All right, multiplied by this case, guys, 60. So now let's work this slowly. Let's work this slowly, right? 1 minus 0.167. Remember, this is BODMAS that we're looking at. So brackets first. 1 minus 0.167. Let's go. Let's go. Let's go. So now that's 1 over 1 minus 0.6 multiplied by 0.833. Okay. All right, still multiplied by 60. Now, in this case, we then take the second bit, right? The second bit is now multiplying these two together. So 0.6 multiplied by 0.833. What's the number that you get? Let me know what your calculator is saying. Zero 0.4998, right? Multiplied by 60. Okay, perfect. And if we subtract those two, now what we'll do is we just round this off to 2 decimal places. So this would then equal 1 over 1 minus 0.5 times 60. We haven't even touched the 60 yet, but we're going to get to that. We're going to get to that, which is now 1 over 0.5 times 60 million, right? So if you put 60 million on top of that equation, you say divided by 0.5, what's the number that you get? 60 divided by 0.5. Guys are on, man. It's 120. Absolutely. It's 120, right? And that's what is the case as soon as you add government spending. As soon as you add government spending, you realize that the equilibrium has moved and it has increased. Okay. So we just basically have shown that through a graph and so forth. Guys, next up we have your 18.2, which is introducing the foreign sector. Allow me to do the following just for today. It's not like me to skip work. We honor the dream by doing the work. But I would not want to just push things for the sake of pushing things. So for now, I do think we've covered quite a lot of material. I don't want to just push things for the sake of it. Let's say we end this today here. Let me know in the chat if that's fine or whether you've got enough energy to continue. I'm happy either way. But I do think that for now, we have gone through quite a bit, and I'd want to stop just to make sure that, we are more or less still fresh and we're still good to go for the next time we meet. Let me know if that's fine with